Greetings everybody, I'm the CS tutor and today I'm going to talk about one of the oldest sorting algorithms known as bubble sort. This video is divided into 4 sections: pseudocode analysis, simulation of a test case, improvement done on the pseudocode, and time complexity of analysis of bubble sort. So feel free to move on any part of the video you want. So first, bubble sort is a comparison-based sorting algorithm that compares an element with its corresponding neighbor until placing an element in its last position. It does this process on every element found in the array. So here we have an array A of n elements, indexed from 0 to n minus 1. So the outer for loop has to iterate over all the elements from 0 to n minus 1 in order to place them at their final position. The inner for loop is responsible for comparing the main element with its corresponding neighbor. If the neighbor is found less than the element, it switches those elements. As you can see, the inner for loop at each iteration will run from 0 to n minus 1 minus I. Why is there an I here? Because at each iteration, as I said, we are placing an element at its last position. So no need to iterate over all the elements again. How does bubble sort an array A? First, it iterates on the first element of the array. It compares it with its corresponding neighbor. Here, 9 is greater than 7, so no need to swap. We continue the iteration although 9 is greater than 7, because here j iterates from 0 to n minus 1 minus I. 9 is greater than 1, so we swap them. Also 5 is greater than 9, so we swap. The same goes for 4. Yet 11 is greater than 9, so we don't swap them. You can see here that 11 now is in the last position and its final position in the array. So no need to iterate and reach 11 over again. So that's why we utilize I. We continue sorting algorithm on the rest of the array, which is 7, 1, 5, 4, and 9. We repeat the same process we did for j equal to 0 to j equal n minus 1 minus I. So here 7 is greater than 1, so we swap them. The same goes for 5 and 4. Nine is greater than 7, so we don't swap. 9 now is in its final position. We continue the sorting algorithm on the rest of the array. We start again from j equal to 0 to j equal n minus 1 minus I. Here, only 5 and 4 are switched. Although now, you can see that the array is sorted 1, 4, 5, 7, 9, 11. Yet, we have to continue the iterations and compare the neighbors without swapping them, because the outer for loop will iterate from 0 to n minus 1. So how can we fix this? How we can tell bubble sort that if the array is already sorted, no need to continue and check if there is any element that needs to be put in its final position. We can take an advantage of the fact that whenever there is no swapping occurring here, then the array is sorted and no need to continue iterating in the outer for loop. So what shall we do? You can place a flag here. Initialize it to false. If there is swapping taking place in the inner for loop, you can set flag back to true. And then you check at the end if flag is still equal to false, meaning no swapping occurred in the inner for loop, then no need to continue iterating over the rest of the element, and the array is now completely sorted. So we break. Although we have managed to find a way to make bubble sort more efficient, this way has proven no good in the time complexity of bubble sort. So let us now analyze the time complexity of bubble sort. What is the worst case scenario for bubble sort? The worst case scenario is when the array is completely sorted in decreasing order. Meaning, I have 10, 9, 8, 7, so on. This 10 will have to travel n-1 places to be placed in its final position. 9 n-2, 8 n-3, and so on for the rest of the array. So we have n-1 plus n-2 plus n-3 plus 1 plus 2 plus 2 plus 1 for the whole array. This summation simplifies down to n times n-1 over 2. Here, you can break it down more to be n squared minus n over 2, which is n squared over 2 minus n over 2. This is clearly big O of n squared. Now what about the best case scenario for bubble sort? Clearly, if the worst case scenario is to place an element n-1 or traverse an element n-1 times, the best case scenario is to never traverse an element and put it in its final position, as it's already in its final position. So the best case scenario will be a sorted array. For example, 1, 2, 3, and 4. Here, no need to swap, and the inner for loop will never swap two elements. Now let's see the average case scenario, which is usually what we will have whenever we sort an array. Sadly, the average case scenario also simplifies down to big O of n squared. For example, let us say on one iteration we swap, the other one we don't swap, and so on. So we will have n-1 plus n-3 plus n-5 and so on. Also, this summation will sum down to big O of n squared, which is similar to the worst case scenario. This has been the CS tutor explaining bubble sort. Thank you for watching.